Chapter 8 is 100% dealing with rules on exponents. They are going to play around. When I look at Unit 8, we have properties of regular exponents. We're going to have properties of rational, otherwise known as fractional exponents. We're going to be talking about how to simplify those, how to simplify radicals, and the difference between rational and irrational numbers. That's what we're going to be doing for Unit 8. This unit, even though it only has 5 sections, is going to be the type of unit that looks easy, but is so easy to make simple mistakes. So my goal to you is to explain to you not just rules, because we have a lot of rules, but my goal is to explain to you where these rules come from. That way you don't have to memorize a bunch of rules, and you just know how to use them and why they are written down this way. So here we go. The first thing we're going to do when we talk about 8.1 is we're going to talk about exponents. What is an exponent? An exponent is the number of factors that are being multiplied together. When you see, let me zoom in on this. When you see 4 to the third power, this is the exponent on this base of 4. It means you have 3 factors of 4 multiplying each other. It means we have a 4 times a 4 times a 4. It's not 12. It's 4 times 4 is 16. 16 times 4 is 64. If there's a 5 in front of it, 5 times 4 to the third, the 3, that exponent only applies to the base that it's on. It only applies to this number. If there's a 5 in front of it, the 5 multiplies the 4 times 4 times 4. And I say that because that's where you might get confused when we deal with a bunch of different things. Exponents are merely how many factors of multiplication. Which then brings us to negative exponents. Oh, what's a negative exponent? Does that change it to be a negative? No, it means it's the opposite of groups of multiplication. It means instead of groups or factors of things that are multiplying with each other, we have groups or things that are dividing each other. So when you look at, let's just say we're looking at rule number 4, and we have a negative exponent. If there is a negative exponent, what it means is instead of you having n factors of a multiplying each other, translation, if this was a 3 and that's a 4, instead of having 3 groups of 4 that are multiplying, we're going to be doing 3 groups of 4 dividing. The easiest way to turn it to division is to move it from the numerator to the denominator. This is 1 divided by a over n. So negative exponents really just move it from the numerator to the denominator, and it becomes a positive exponent down there. Or it goes from the denominator, negative exponent, to the numerator. It's the opposite of. If you need to see it with numbers because variables are not, let me make sure that I have my pen color. If you need to see it with the number, 5 to the negative third is the same thing. Instead of 3 groups of 5 multiplying, we have 3 groups of 5 dividing. The easiest way to write that is in the denominator. And then what we have to do is then we have to figure out what 5 times 5 times 5 is. 5 times 5 is 25. 25 times 5 is 125. That's how it would work. Simple. Okay, so let me scoot that down. So we've talked about exponents. We've talked about what a base is and what the exponent is and how the exponent only applies to the base unless there are parentheses. Notice that the 5 does not, we don't have 3 groups of the 5. We only have one of them because there is one factor of the 5. As a matter of fact, if you don't see an exponent, it's an invisible one, just in case you didn't know. Those are our major concepts, and then that brings us to these 6 different rules. And the 6 different rules will never be this simple. Everything that you have are going to be as complicated as they want to get. When I look at number 8 and number 9 and number 19 and number 27 and number 28, these are the examples that we're going to do together. They never just give you one variable by itself. They always throw in a k, and there's a k to the third and a j and some numbers. We call those coefficients. They're really going to mix up all of the rules and put them together. So the first thing that I need to say is that these rules apply to all the problems below, except for you need to realize that they're going to combine several of the rules together. So let's just talk about the rules, and then we'll talk about how you apply them. Here you go. If I have two things with the same base and I'm multiplying them, a shortcut would be that I can add the exponents. If you want an example of that, let's say I had 4 to the third power, and I'm multiplying it by 4 to the fifth power. These two bases are the same. When you see A and A as the rule, we're not really saying for A, we're saying that it could represent anything that has the same base as each other. Is 4, the base of 4, and the other base of 4, are those the same? If they are, then what we can do is we can add their exponents. 4, I'm sorry, my handwriting's really not great. 4 to the third times 4 to the fifth, you would just add their exponents as the shortcut. The 3 plus the 5 means that it's 4 to the 8th power. That's how it works. That's the shortcut rule. Notice the base does not change. I didn't do the 4 times 4. I just left it. And the whole reason behind this is very simple. Look at 4 to the third. Remember I told you it means 3 factors? It means you have these 4 times 4 times 4, and then you're multiplying it by 5 factors of 4. There's 5 of those. Now, if you have 3 factors of 4 multiplying 5 factors of 4, how many factors of 4 are multiplying each other? You have 8 of them. The rule matches what we talked about at the very beginning of the problem. What is an exponent? It's how many factors of multiplication there are. So I hope that makes sense to you. I guarantee you that on a multiple choice test, this multiple choice test, if I have 4 to the third times 4 to the fifth, one of the choices is going to be 16 to the 8th power. Another choice would probably be 16 to the 15th power, because some of you will multiply the exponents. Your goal is to know that I only add exponents because it represents how many groups or factors of multiplication there are. Okay? If you're dividing, you can subtract the exponents. For example, if you had 7 to the third over 7 squared, remember what it means. It means that you have 3 of those and 2 of those, 2 factors of multiplication. It's just going to end up reducing. If you subtract the exponents, it's the same thing as what it represents. If you have an exponent outside of parentheses, you can multiply the exponent to the top of a fraction or the bottom of a fraction. How come? Because it's what it represents. For example, I did something funky. Every now and then my pen does not want to write. There we go. Okay. So for example, if I had, let's say, 7 to the third power, and I have an exponent outside of parentheses, this shortcut rule says multiply the exponents. 7 to the 6th. When you're multiplying, it's because you have 2 factors of 7 to the third times 7 to the third. There's 2 of them, 2 groups of these. And this means you have 7 times 7 times 7 And this means you have 7 times 7 times 7, and now it means you have 6 of those. They all represent how many factors of multiplication there are. So all these rules represent that. I talked to you already about negative exponents. Do not change the sign. This one may look weird to you, but anything to the power of 0 simplifies to 1. The easiest way I can describe that to you is to go back up to this number 2 and say, what if m and m were the same thing? A to the, let me write that over here. A to the m over a to the m. What if they were the same thing? And you try to apply rule number 2. You would do m minus m, which would make a to the 0. Well, how many times does this go into that? It goes into itself 1 time. Because something divided by itself is 1, we have to define anything to the 0 power as 1. And that's a hard concept for a lot of students to understand. But anything divided by itself is the same thing as 1. So trying to make this rule and this rule the same thing, that's why they defined anything to the 0 power as 1. And if it doesn't say, there is always an invisible exponent of a 1 because you have one factor of a. Okay? They're going to mix all these things together. And our job is to apply the rules piece by piece, step by step. I've given you some advice on number 7 through 32 and so on. Now the thing I need to warn you about, this test is no calculator. The chapter test, you are not allowed to use a calculator on this chapter test. What does that mean? That means as you're doing this worksheet, I can already see that 5 of you have borrowed a calculator from me, and you're not going to be allowed to use this calculator on the quiz nor the test because that's how it goes. So you might as well get used to not using a calc during this unit, especially on this worksheet. Okay? So let's do some examples. You have the worksheet in front of you. If you would like to do this on your worksheet, I would recommend that you do that. Number 1, it says expand and evaluate. So 4 to the 3rd power means 4 times 4 times 4. There are 3 factors of 4. Expanding it means, well, what does it represent? Evaluate means, figure it out, simplify it. What does that equal? Now, some of you want to use the calculator on this. We're going to have to do it by hand. What I would recommend that you do is that you multiply the first 2 numbers, 4 times 4. Once those 2 multiply, you only have one other thing to multiply it with, which is the other 4 there. If you want to do it this way, you can, if you know how to do that. But I know what 4 times 16 is. 64. That's as easy as it gets. But I want to use a calculator. You probably shouldn't because you won't get one of those on the test. Okay? By the way, they're not going to test you on this. Your test questions will look more like 7 through 21. This is too easy for your test. It's just trying to see, do you understand the basics? Let's jump to something harder. Let's jump to something that's going to mix a couple rules together. Number 8. Number 8 says, negative 4xy squared in parentheses multiplied by 15x to the 4th y to the 5th. Now I want you to see that we wrote down something up here. These rules only apply when the bases are the same. A's have to combine with A's. B's have to combine with B's. I didn't subtract the exponents here because B and A are not the same thing. That means the variables have to match for this stuff to work. We're going to multiply these things, but I can only put the x's together with the other x's and the y's together with other y's, and the coefficients with the other coefficients. This is a multiply problem. Parenthesis, parenthesis, parenthesis. There's nothing outside of parentheses that have exponents. So I'm going to take this and this, and I'm going to multiply those two things. That was so weird that those two things disappeared. I don't know why. So what is negative 4 times 15, 30, 45, 60? Negative 60, right? A negative times a positive is negative 60. What I like to do is I like to do it piece by piece. I do the numbers. I multiply them. I multiply x times x to the 4. Now look at, I have 4 factors of x that are multiplying each other. I have 1 factor of x multiplying 4 factors. I'm hoping you know there's an invisible 1 here. That's rule step 6. And then you can apply rule number 1. Add those exponents. X to the, what do you think it is? Go ahead and say it out loud. If you said 5th, you were right. You're going to multiply your y's. Because you're multiplying them, what do I do with the exponents? You're going to apply rule number 1. It's going to be y to a certain power. If you know what, or you think you know what the exponent will be, say it out loud. I agree. You cannot put the x and the y together because they're not the same base. You can't mix the negative 60 and the x together because one's a variable, one's a number. This is your answer. Nice beginning entry-level problem. There's lots of places for you to mess up. That's why I think this unit is going to be tricky. Let's look at another one. Let's do several more together before I let you do some independent practice. Number 9 is very similar to number 8. It's still multiply. I have a 4k that's multiplying the 7j squared k to the 3rd. There's no exponents outside of parentheses. So all I have to do is multiply. I'm just multiplying the 4k times this. Numbers can multiply numbers. 4 can multiply the 7. I would do that first. What does that make? Go ahead and say what you think it is. Now this is a k and this is a j. Those are not the same base. I cannot combine them. I cannot use the rules above because they're not the same variable. So what do you do with j squared? You just leave it there. And why do I write j squared next? Because math teachers and state tests always write these in alphabetical order in their final answer. J becomes before K in alphabetical order. That's why they will write that letter first. You can choose to write it in either way, but I prefer it to be the same way that it is going to be on SATs for those of you who are going to take that in your junior year or senior year. Should be junior year though. Now what about this k? Can it multiply and combine with this k to the 3rd? Sure. You have 3 factors over here. You have another k over here. You're multiplying them. Apply rule 1. How many factors of k do you have? K to the what power? That's it. It's so simple, but yet at the same time, it's so simple to make a simple mistake. And so you have to pay attention to the details. Otherwise, that's what's going to determine who gets A's, B's, C's, or F's in this class. Okay? I jump to number 19 next. If you ever have an exponent outside of parentheses, I usually don't show you any other shortcuts than saying, well, you have 3 factors of this. Let's write out those 3 factors. 7g to the 4th h to the 0, that's 1. 7g to the 4th h to the 0, that's 2. 7g to the 4th h to the 0, that's 3 factors of that. That's what it represents. And so, this is a reason why a 7 multiplies a 7, that's 49, multiplies another 7. So I'm just going to write 7 times 7 is 49 times 7. I'm going to put it over here. 7 times 9 is 63. Carry the 6. 28, 34, 343. Is that what you guys got? Notice I had to do my work off to the side because no calculator on this test. I have g to the 4th times another g to the 4th times another g to the 4th. I have 4 groups of g that are multiplying, 4 factors. And now I have another 4 factors and another 4 factors. Do you know how many factors this is going to go to? If you know what the exponent is, go ahead and say it out loud. If you said 12, you're correct. Now h to the 0. Just like I think it was rule 5 in your notes. Anything that has an exponent of 0 simplifies to 1. 1 times 1 times 1. Do you want me to write times 1? Do we have to write times 1? Let's write times 1 and let's see if that helps us. Times 1 times 1 times 1. Do I know what 1 times 343g to the 12th is? Then I would just write it like this. Multiplying by 1 does not need to be there this time because we already have the 343g to the 12th. That's our final answer. If you're like, why didn't you put the 1 there? Because 1 times anything is itself. It simplifies. I only have 2 more examples. And then I'm going to give you some independent time. It says simplify each expression, write the final answer using only positive exponents, no negative exponents. So what I'm going to do on number 27, there are other ways to do this, but because there's a 3 outside of parentheses, it represents that there are 3 factors of everything inside here. The first thing I do is expand it. I have one of these, I have another one of these, I have another one of these. There's 3 of those in the numerator, aren't there? And then I have 3 groups of these in the denominator. I haven't simplified it at all. All I have is I have 1 group, 2 groups, 3 groups. That's what the 3 exponent outside of the parentheses represents. So at this point, you have a couple choices. You can try simplifying following rule number 2, or you could combine using rule number 1, or so on. Let's use rule number 1 first, just because that's the order. And let's just do the numerator. I have x times another x times another x. That is x to the 3rd in my numerator. I have a y to the 7th times a y to the 7th times a y to the 7th in my numerator. 7 factors and 7 additional factors, and 7 additional factors means I have 21 factors of y in the numerator. In the denominator, I have 5 factors of x, another 5, and another 5 make 15 factors of x. 3, 4, 5, 6, 7, 8, 9 factors of y. And then I would simplify. I could subtract. But if I subtract, I'm going to have x to the negative 12. Can't leave it that way. A lot of times if you have x to the, and you subtract and you have a negative exponent, sometimes it's just easier to say 3 minus 15 is negative 12. Leave the x's in the denominator. That's going to make it easier for you. You could think of it like I have 3 of them up here and 15 of these guys down there. That's a lot of x's multiplying. 3 of them, and 3 of them are going to reduce, and you're left with 12 of them in the denominator. As far as the y's go, 21 I can subtract from 9 is y to the 12th. Now these are not the same base. They cannot reduce with each other, so don't try to do that as well. By the way, there are other ways to do this. Sometimes it's easier to simplify it first. For example, let me just show you one alternate way. Don't write it down, just watch. If I would have reduced x and x to the 5th to just x to the 4th, and y to the 3rd goes into here, I have y to the 4th. If I subtract 7 minus 3, I have left with 4 up there. We could have simplified it first before we did the expansion, and that might have saved a little bit of time. Just so you know. My last example is 28 because I remember when I taught Math 1, this was my #1 most missed question. It was a multiple choice question on the test, and I can't tell you how many kids got the wrong answer. So let's just see. 7x to the -1. The 7 has an exponent. How many 7s do I have here? I have 1. The -1 only applies to the x because there's no parentheses here. So I'm going to do this. Before I even start the problem, I'm just going to circle this so that you realize this is separate. The 7 stays where it is. To write this as a positive exponent, on your rule number 4, that you have that a to the -m, if something's negative, it turns into a positive when it moves from the numerator to the denominator. Well, what happens to the 7? The 7 is in the numerator. It stays there. I know this is a weird answer, but your final answer for 28 should be 7 over x. And I'm curious, how many of you, when you did number 28, that's what you got? Raise your hand if that's what you... Okay, good. You wouldn't have missed that most missed question from Math 1, just so you know. We're going to stop your notes right there.